Hi, we discuss p-values. So we have two ways to implement the statistical testing. So one way is just use rejection region. So test the method one, the check if our test statistic, in our case, the t statistic, falls in rejection region. And the second way is the compare p-value with our significance level, alpha. And the rule is always simple. Actually, the p-value is more than alpha, then we don't reject H0. P-value is less than alpha, we reject null hypothesis. And what's the p-value? The p-value is the probability that a more extreme event than our sample happens under a null hypothesis. So think about the two-sided test. H0 is mu is equal to mu naught, and H1 is mu is not equal to mu naught. Then suppose our test statistic is t, lowercase t, okay? And we have distribution of test statistic. Okay, so t sub n minus 1. And suppose we observe the t here, okay? Then our observation, our test statistic from sample. So test start from sample. And how extreme this situation is. We think about the probability that more extreme, excuse me. Think about the probability that the more extreme event happens under null hypothesis. Then more extreme event is defined as test statistic falls in this area. So this area, the total of these two areas, this is called p-value. So p-value represents the probability that a more extreme event than our sample t happens under H0. So since our test idea, so the statistical testing idea is that when t statistic falls in extreme range under H0, then we reject H0. So that means, so actually if the test statistics falls in the alpha % of extreme values, then we reject H0. So actually by the definition of p-value and the idea of statistical testing, we reject H0 if and only if p-value is less than alpha. So if our test statistic is extreme enough, then we reject null hypothesis. So this is the idea of p-value. And p-value is different if alternative hypothesis is one-sided. So basic idea is that, okay, so suppose H1 is mu is larger than mu naught. Okay, so this the second case. Then, okay, so t distribution is here. So this is t sub n minus 1. And okay, so alternative hypothesis is mu is larger than mu naught. So under alternative, the t statistic is likely to be large, right? So t statistic is x bar minus mu naught divided by something. So if mu is larger than mu naught, x bar is likely to be larger than mu naught. So t is large. So that means has a tendency, large value of t, basically this support h1. So this support h1. And the smaller value of t, so we support h naught as a tendency. Okay. Then what's the rejection region should be, and what's the definition of extreme values under h naught? Then that should be the right tail of this distribution. So if we have t statistic here, then p-value should be larger than this value. So this is p-value. For two-sided test, we also think about the negative side, the left tail, but the left tail is not really the extreme under h naught. So this would rather support h naught. So this should be defined as p-value. So it's a little different. And the third one, just that we flip the relationship between the center. So we omit this, but we can define p-value in the same way. So now one example. So mass PhD salary example. What's the p-value? And think about the two-sided test first. So H1 is mu is not equal to 79,500. Then p-value is both sides of the test statistic. So remember that we have test statistic of negative 0.9465. So around here, negative 0.946. Okay. Then this is two-sided. So think about the other part also, and the total of this area and this area, this total is p-value. So this is actually this probability of capital T is absolute value of capital T is larger than 0.946, and that is 2 times p of t is larger than 0.946. That means this area and times 2. And that is 2 times 1 minus p of t is less than 0.9452. So I mean this yellow area is not directly calculated from our function. So we think about the complement. Then we subtract this from 1. Then we multiply this by 2. Then we get the p-value. And that is actually equal to 0.38. So this p-value is larger than 0.05. So at 5% significance level, we reject null hypothesis. We do not reject null hypothesis. If significance level is even 10%, 0.1, still larger than 0.1, so we do not reject null hypothesis. And the below is the sample code, sample R code. So we calculate the sample size at first by length function, and the df is n-1, and capital T is the test statistic. Actually, this is not recommended. Capital T is sometimes reserved as the true TROUE. So maybe we should say, I don't know, maybe capital T1 or something. Then it avoids more errors. Okay, so mean minus our null hypothesis divided by standard deviation divided by square root of n. Then the threshold is obtained by this QT function. So yeah, so this determines the threshold value for rejection region. So this is 2.46, 2.446 or something. Yeah, and what's the p-value? The p-value is calculated based on this. So this is exactly actually the same as this. Right? So you can get the p-value of this. Okay. So we get the p-value manually from this. So another example. So example, the hypertension data. So average systolic blood pressure of hypertension patients in a hospital is 162.6 millimeter Hg. Okay, so this is the sample average, so the X bar, kind of. And 10 patients, so this is N, in the hospital took the prescription, and their blood pressure after 4 weeks are these. Okay. So, oh, sorry. This is the average blood pressure in the hospital. So this should be mu. This should be mu. And after the 10 patients, after prescription, that they measure the blood pressure again. So this is the for small sample case. So for 10 patients, after 4 weeks of the prescription, the average, actually 10 observations are here. So maybe I would say this is X1 to X10. And from this, you can calculate X bar. And test if the blood pressure decreased significantly after taking the prescription. So our null hypothesis is the mu is 162.6. So even after prescription, blood pressure does not change. And alternative hypothesis is it actually decreased. Then we can use the t.test function to implement this. So the data is here, x1 to x10. Then we can use the t.test function and the data, null hypothesis, and alternative hypothesis. Last time we did not put anything, but the default is two-sided, but here alternative hypothesis is less. So that means mu is less than 162.5. Then this is the test result, the t-statistic negative 2.16. So actually it's a little lower than the 162. The X bar is a little lower than 162.6. And the p-value is 0.02952. So actually this is less than 0.05. So if significance level is 5%, that is standard number, we reject the null hypothesis that blood pressure does not change after prescription. So this drug may be useful significantly. So this is how to implement t.test in R. So we have studied one example for two-sided test and one example for one-sided test. And in general, in the R t.test function, it gives p-value. So we have to use p-value to decide. It does not give the rejection region.